is, first part I was given is that angle G, start with that because it's the easiest, angle G is congruent to angle O. And that came directly from the given information. So I'm just going to hook it up to a given block. Then, our second angle pair, AAS, the angle 1 is congruent to angle 2. Alright, so how did I know that those were congruent? Well, I knew that I was given that segment EM bisects angle GEO. So given that. But because of the format of this information and what's written on this block, I know that I can't connect those right away. So I have to say how I figured it out, and that was using the definition of an angle bisector. I knew that, here I have a segment is the bisector of an angle. That's what this information looked like. And that gives me two congruent angles. And those are the two congruent angles I figured out in my proof. Alright, moving on. The last piece is that EM was congruent to segment EM. Alright, with all three of these inputs written, I could conclude that triangles were congruent. Triangle GEM is congruent to triangle OEM. However, I haven't hooked this up. See, these two lines of reasoning came from the givens, right? This one came from somewhere else. And I know that it came from the picture. I was pretty sure I was using reflexive property, and here the input for reflexive property was picture, and the output was a set of either congruent segments or congruent angles, and in this problem it's going to be the congruent segments. So I've got it all hooked up. Once we have an entire chain of blocks where there are no missing inputs, where everything is covered by a given or a picture or a fully connected block, and where one block's output matches the proof statement, then we know that a logical argument has been made.
So when we mark our picture, we're going to just read the given and mark everything that they tells us, okay? That they tells us?
Yes. Or the word of the day tells us.
Tells us. Okay, so starting off, segment AD is bisecting two different angles. One of them is BAC, and the other one is BDC. So let's take a look at this first angle. You guys look up here. You don't need the proof box yet. This is, if you don't understand this, you're not going to get it. What's the vertex of this angle? And how do we know? Paul?
B.
No. Cameron, why'd you say, or Mason, what'd you say?
Because it's in the middle.
It's in the middle. A is the vertex, and that angle is being bisected by AD. So go to vertex A. You guys see AD?
Yeah.
That angle is being bisected by AD. So I'll put two arcs in those angles. Now the same thing is happening to angle BDC. And what's the vertex of that angle?
D.
D. So I'm going to go over to point D. That angle is being bisected as well. So I'll put two arcs there. Now how many pieces of information is that?
2.
That's only 2, right? We have 2 angles and 2 angles. That's not enough. And we know that AAA doesn't work. We just proved that as your warm-up today. So what has to be the third piece? Some type of side. So when you look at this picture, which side can we assume will work, even though they said nothing about it? Nathan?
The middle, AD.
Yeah. Anytime two triangles share a side, you're going to put a tick mark. Because that side is a part of both triangles, right? If I separate those two triangles out apart, that's the same segment. So obviously that one will always work. So now that the picture is marked, what shortcut's going to be our winner? Angle, side in the middle, angle. Find that big block. So yours, mine's blank, yours says ASA on it. Okay? Now I suggest to you, you can write on these, that's why I gave you a marker and an eraser. Write ASA over here on the left side on those little notches. Because that shows you what input needs to come into that block. The top has to be an A, the middle has to be an S, and the bottom has to be an A. Now, I really like these proofs because it's actually working backwards. We just proved, we basically just figured out the reason why. It's going to be ASA, right? But now we're going to work backwards to find the information that we need. So let's start off with this very first A on the top. Okay? What is the first angle that I marked?
A.
Yeah, these two right here. And you can't just call it angle A, right? You need to, because there's numerous angles coming off of the vertex A. So we need to name it with 3 points. So how would I name this angle on top right here?
ABD.
A has to be in the middle. It's the vertex.
ABD.
So BAD or DAB. A has to be in the middle. So I'll call it angle BAD. Go ahead and write that on your card.
Oh.
Now, what is the this bottom angle right here? What do I call that?
DAC.
DAC or
CA.
CAD. So I'm going to call it angle DAC. So angle BAD is congruent to DAC. And how did I personally know to put an arc in that picture? I didn't just make it up.
Because you went to school.
What word? The word bisector. So now, look at your little pieces. Those are your definitions and your theorems and your midpoints. Find the little slip that says angle bisector and plug it in to that A. Angle bisector. The definition of an angle bisector. So the inputs have to match. So find the one that has a congruent sign on the right.
That's helpful.
Now, technically, you're supposed to write it out twice. These are literally supposed to match. So I would technically write here, angle BAD is congruent to angle DAC. I don't really care if you do it twice. You don't have to. By plugging them in together, that's telling me that you know that they go together. So if you just want to write it once, that's okay. If you want to go all out and write it twice, that's okay as well.
Wait, I'm confused.
Now, where did I reach this conclusion? There has to be a beginning point. And how did I know that this, I didn't just make it up. I didn't say, oh yeah, I think those are angle bisectors. Neil,
80.
given. It was given to me. So find a little circle that says G. And you can just set it right on top of this block if you want. And put it in that first blank. That is your input to the whole, that's where it started, right? The given. That's where a proof always starts, is the letter G. And that was given to us. That's why we know these angles are congruent. That is the first angle in ASA. Does that make sense so far? Okay, so now let's go on to this S. What does S have to be? A side. And what's the only side that we know is congruent?
AD.
AD, so segment AD is congruent to itself. Now there has to be a property or a theorem that comes before it, unless if it was in the given. And do you see AD is congruent to AD in the given anywhere? No. So this is just a property that we've been practicing for the past 3 months. What property says AD is congruent to itself? So find, good job. It is the reflexive property of congruence. So find the little strip that says reflexive POC and plug that into the input. Now, like I said, you don't need to really write it twice. Technically, it should say AD is congruent to AD on the left, AD is congruent to AD on the right. They plug into each other. And how did my brain get that information? We have to have an input into reflexive. It's either going to be a P or a G. What do you think P stands for?
Picture.
I got it from the picture. So if it wasn't in the given, that means I looked at the picture and I realized, hey, these two triangles share a side in the middle. And we know that anytime two triangles share a side, that's our reflexive property. So we got that information by looking at the picture. So put a P there. That's the difference between the G's and the P's. Does that make sense? And then the last one has to be an angle, right? That's why we put an A there. So what rectangle is going to go into this input?
BDA and ADC.
Yeah, it's these two arcs over here. So BDA. So angle BDA is congruent to angle, what's the bottom one? CDA. Or you could call it ADC, but A or D has to be in the middle because it's the vertex. And how did I know that information?
Picture.
Angle bisector. And that was from the given. So put a G in the front.
Wait, so is this angle bisector? Do we use this one?
Yep.
Even though there's
You can scratch it out if you want or use a blank one. It's up to you.
Then turn it upside down.
Or you can turn it up. Yeah, that's a good idea. Turn it upside down. So that the congruent sign is on the right. Okay, do we have three pieces of information that all have a beginning, they have a reason, and they tell me my A and my S and my A?
Mm-hmm.
Yeah, so our proof is done. We have now proved that triangle, so all of this information winds down and comes to this final output, my proof, what I'm trying to prove. Triangle, now I'm going to call this A, B, D, but what do we have to remember when writing a congruency statement? It has to match in corresponding order. So it's congruent to triangle. Now I called the top one A, B, D. So if you think of this as a kite, I start at the one arc, I go out to the wing, and then I go to the two arcs. So what do I have to name this angle or this triangle on the bottom?
ACD.
A, C, D. You have to write it in corresponding order. And we're done. We just did a proof.
That was not bad.
All right, let's go ahead and mark up this picture together, and then I'm going to let you practice these on your own, see if you can do it on your own real quick. So take a look at the given. What is the first thing we always have to do? Yeah, go ahead and erase. What's the first thing we have to do?
Find the
Together.
postulate.
Figure out, which big block we're going to use. Which shortcut are we going to use? And what's the only way we can really do that?
By looking at the picture.
Yeah, by marking up the picture. So look at the given. This proof might look familiar to you. C is the midpoint of BD. How do I mark that in the picture? C is the midpoint of segment BD.
Put like a tick.
2 tick marks. That means BC is going to be congruent to CD, right? Yeah. But C is also the midpoint of AE. So look at segment AE. C is in the middle. How do I mark that on the picture? 2 tick marks. So how many pieces of information do we have so far? 2 pieces in each triangle. We have basically side, side. Now we have a possibility. We know side, side, side actually works, right? So we could come up with another side, or
The angle.
we could come up with an angle. So in this case, something has to come from the picture because we're out of givens. Something has to be like something that we see in a picture, and we've been practicing it for 3 months, so we just know it. Yeah.
The C or the A, E, and BD are vertical angles.
Good. ACB is this angle right here. ACB is vertical to ECD. Vertical angles, those hourglass angles, right? Or if you want, they're the scissor angles that form an X. Those angles are always congruent to each other. We've known that for about 3 months because they're vertical angles. So now, what big block are we going to use? SAS. Side, angle in the middle, side. So find your SAS block. And I'm going to give you a couple minutes to work through this one on your own. There's your final answer. That's what's your proof. So this would be your final answer right here. Oh, yeah, you got it right. Good. Okay, now I want to show you real quick